Hi, now we are going to see about problem in the transformer, the transformer functions and transformer ideal transformer. Here they are used the ideal transformer, and we have to retrieve information from our brain about the transformers. So the problem says that following arrangement consists of an ideal transformer. So we have to go for what are the theories being know, and we ready to apply those theory into this problem. For ideal transformer, an attenuator which is attenuate by factor of 0.8, we have the attenuates value, that is 0.8, and AC voltage V Wx1 equal to 100 volt is applied across Wx to an open circuit voltage XYZ1 across YZ. Next, an AC voltage. Here they applied a separate voltage till here, and then after that they are applying another voltage called XYZ2, which is equivalent to 100 volt, is applied across XY to get an open circuit voltage of Wx2 across Wx. Then we have to find the values, that is Vyz1 divided by Vwx1 comma Vwx2 divided by Vyz2. Here we are inputting that Vwx here and finding the value. We are getting the open circuit voltage Vy1, that is they are asking Vy1 Z1, that is we have to find the output divided by input voltage. Here we have to reciprocal that. We have obtaining the voltage Wx2, that is output voltage we are writing here, and input voltage Vyz2. So we have to find the output divided by input values, that is automatically we say as gain value. For applying these two voltages separately, we have to find the values of gain using this AC voltage itself one time. Again we have to find this value in some next step. So we have the circuit as the problem given to us is the arrangement will be like this. So we have the Yx, that is input terminal, and Yz, and we have separately we can apply anywhere that voltage can be input voltage, because in the first step, in first case they told that they are applying voltage between the AC voltage between W and X. In next step, in the next case they are applying the Yz terminal to get the output from Wx. So we have to ready for that. Before that, in this problem, in this circuit, we have to get the values of the transformer equation. That is, we know that this 1:1.25 is the turns ratio between the primary and secondary. According to this first case, it's one is the, that is this value is primary turns and this value is secondary turns, and according to second case it's becomes primary and becomes secondary. So we have to ready to apply those values in according to the cases we have now. So they told they are applying the AC voltage in the first. We are going to choose the first case first, and we have the input voltage 100 volt. We know that the transformer ratio can be equivalent to the applied primary voltage and our primary voltage divided by secondary voltage, which is also equivalent to secondary voltage divided by secondary current divided by primary current. So we have to know that first of all. So we have the xy bar z1, that is yxy, so it is equal to m2 by m1. So we know that M2 by M1 is transformer ratio, that is we already have in 1:1.25. We can write it as 1.25 because it's 1.25 divided by 1, which is also equivalent to 1 by 1.25 is equal to 100, which is equivalent to multiple of 100 because it's an input voltage. So we are getting the secondary voltage as the 125, which is not equivalent to output voltage. So we have to find the output voltage. To find that, we have to, because it's alternating after getting here, the current getting attenuated from here to here, so we will get some reduction. That attenuation factor also given in the problem as 0.8. So we have to multiply that attenuation factor, so we will get 125 multiple of 0.8, which gives us 100. In this output voltage is 100, and that output voltage divided by input voltage they asked in the problem, which is we have to find in this problem. So we will get 100 by 100, that is the answer of this first case. Here we have Vy dash Z1, that is the secondary voltage. We need to find the value of the output voltage, that's why we multiply with the attenuation factor. And again we have the second case, that is in second case this Yz having the input voltage as 100 volt, which is AC voltage, and find that we have to, it's attenuating to the transformer, that primary turns, and again it will get the secondary turns. So we have to multiply the attenuation factor, divide the attenuation factor in here itself, because it's getting opposite to that getting the attenuation, so we'll get dividing. So 100 by 0.8 will give us the 125. We already know ratio between that M1 divided by M2, that is transformer ratio, that is M1 is 1.25 is the turns, that is transformer ratio of this secondary. So we'll get 1 divided by 1.25 multiple of 125, which give us 100. So we'll get the output here 100 and input 100. So we'll can say that what the equation they asked, that is Vwx2 divided by Vyz2, that is 100 divided by 100. Thank you. Your comments are welcome.